Welcome back to Mastering C++ 20 Features. This is the first lecture on coroutine. But before we begin our journey with coroutines, we need to understand the way conventional functions work. Conventional functions or subroutines are the regular functions that we are used to. Functions running parallelly or in a serial process. Functions invoked by other functions or passed as callback to other functions. Here, for example, main, foo, and bar are functions or subroutines. Main calls foo and foo calls bar. Subroutines follow the normal stack process. Each subroutine has its own stack frame. The stack frame consists of parameters that it received from the caller, return address or pointer to the caller, and storage for local variables. Execution state, which is activation record, which we will discuss in the upcoming slides. When no function is being executed, the stack frame is empty. For example, here on the right side, the stack frame is completely empty. When the program starts and function or subroutine main begins execution, it is pushed into the stack frame. At this point, the execution state of main is associated with an activation record. What is an activation record? Activation record keeps some temporary runtime state associated with the specific invocation of any function or subroutine. For example, in this case, main has its own activation record. Activation record consists of storage for functions local variable and control flow related information. Next, the execution comes to foo, and foo is pushed into the stack frame. At this stage, the function main preserves its activation record and suspends its execution. The execution is transferred to foo along with some data, that is arguments to foo. In this case, it is void or empty. Then the execution comes to the body of foo and it does whatever it is defined to do. During its execution, the subroutine foo maintains its own activation record, which consists of foo's local variable and control flow related information, that is the return address of foo, which is main, and the address to which function foo may call. In this case, it is bar. Next, the execution comes to bar, and bar is pushed into the stack frame, and bar does whatever it is also defined to do in the body. Finally, bar returns, and on completion of execution, the activation frame of bar is destroyed, and bar is popped out of the stack frame. Next, the execution returns to the caller of bar, which is foo, and foo finishes execution and is also popped out of the stack frame. Finally, the function main also finishes execution and is popped out of the stack frame, and stack frame is empty. Finally, we look into the limitations of subroutines. Regular functions or subroutines are limited in capabilities because a program, client, or user cannot explicitly access the activation record either in running state or in suspended state, cannot pass them as arguments to other subroutines, and function flow is linear and strictly nested. That is, the control passes up the callee when new subroutine is called. For example, the function control passed from foo to bar up the stack frame, or down back to the caller when subroutine finishes execution. For example, the control passed down from bar to foo in the stack frame. A function invocation cannot transfer control to another function invocation more than once. Multiple invocation of the same function creates a new activation record of the target function. For example, parallel execution of foo on two different threads creates a stack frame on each thread, and on each thread there are separate and independent activation records associated with the execution states of foo. Transfer of control to the callee cannot be delayed. The activation record of subroutine cannot be stored and used at a later time. When the callee finishes execution, the transfer controls back to its caller. It cannot be resumed again from its previous activation record, and the activation record is completely destroyed when the callee returns to its caller. For example, the callee in this case was bar and the caller was foo. When bar returned to foo, its activation state was completely destroyed. Here is a reference which you could use to understand more about activation records and the way functions work. I hope you enjoyed this lecture. See you in the next lecture. Thank you. Hello there. If you enjoyed watching this video, don't forget to hit the like button and subscribe to my YouTube channel. If you have any questions or if you would like to start a discussion on the topic covered in this lecture, please feel free to leave a comment on this video. And lastly, if you are interested to learn more about my courses, then log on to my course website, mastering-modern-cpp-features.thinkific.com. Thank you.